Hello guys, welcome to my channel. This is Farhad. I'm here today with another beautiful but hard geometry question. This is one of the questions that appeared on Iranian University entrance exam in 2024. And what makes it particularly hard is that the students have to solve it in almost less than a minute. Before you watch my walk through the problem, you can try to solve it yourself and then watch the video and see the solution. Let's get started. We're given the triangle and also the proportion AC over CG is equal to DE over EF. In this sort of problems, when you're given a proportion and a triangle, more often than not, you're dealing with a triangle proportionality theorem problem. What does the theorem state? The theorem states that if a line parallel to one side of a triangle intersects the other two sides at different points, then it divides the remaining two sides proportionally. As you can see in this picture, ABC is a triangle, DE is parallel to BC. As a result of that, AD over BD is equal to AE over CE. Now, we're given in our problem that AC over CG is equal to 4. This implies that if here is n, then here is going to be 3 times n. And since DE over EF is 4, if here is m, here is going to be 3 times m. Now, the problem is that we don't have a triangle to apply this theorem to. So we will have to create such kind of a problem, such kind of a triangle ourselves and try to use the theorem. I'm going to connect this corner to this corner using a line, and then I'm going to draw another parallel line from this corner to this corner, and I'm going to make that parallel to this line. Now we can easily apply the theorem to ADC, right? We have GC over AC is 1 over 4. And since we're given that AD is 4, we can easily conclude that here is going to be 1. Let me write it. We know that GC over AC is 1 over 4. And we also know that if, let's say that here is, this point is H. GH over AD is also 1 over 4. And since AD is 4, GH, so this is 4, GH is going to be 1. So we found GH. Now we will need to apply the theorem one more time to find FH and then use the Pythagorean theorem to find FG. So what I'm going to do, I'm going to draw another line from here to here. HF is the new line that I drew. Okay, now we know that CG over GA is 1 over 3. We also know that GH is 1 over 4 to AD, right? This implies that CH over HD is also 1 over 3. Let's say that, for example, here is X, here would be 3 times X. This is here and this is here. Remember that 3m is for DF, right? Okay, so now since we know that CH over HD is 1 over 3 and EF over FD is 1 over 3, we can easily conclude that this is the reverse of the triangle proportionality problem theorem. And what does it mean? It means that we can easily assume that this line is parallel to this line. And since these two lines are parallel to one another and GH is parallel to AB, we can conclude that here is a right triangle. So FG power 2 is going to be GH power 2 plus FH power 2. This is Pythagorean theorem. Now, we have GH is 1. So our job here is to find FH. How do we find FH? Look, we can write, according to the theorem again, FH over CE is equal to FD over DE. And this is equal to 3 over 4. Since we're given that CE is equal to 1, we can easily write that, we can conclude that FH is equal to 3 over 4. And using Pythagorean theorem and this 3 over 4, we can write that FG power 2 is equal to 1 plus 3 times over 4 to power of 2, which is equal to 25 over 16. Or FG is equal to 5 over 4. Beautiful.